Hello friends, welcome back to the channel. In this video, we will learn how to deploy a deep learning model as an API using FastAPI, Celery and Redis. We'll also manage GPU memory using PyTorch and pynvml. We are going to build everything from scratch, step by step, and by the end of this video, you will learn to build an API for your deep learning models, run inference asynchronously using Celery, use a Redis as the background queue, and will also manage GPU VRAM intelligently. So in short, we can say at the end of this video, you will have your own working inference API that can classify images asynchronously. Now, what is the problem? The problem we are solving is simple. When you deploy a deep learning model directly in a web API, it becomes slow and unresponsive, especially if multiple users are sending requests. To fix this, we built a pipeline where FastAPI receives the request, Redis queues them, and Celery Worker process them in the background. This way, the API never gets blocked and GPU memory stays under control. Now we'll move on to the architecture, how we're gonna do everything from end to end. So first of all, a user upload an image through FastAPI. FastAPI send this request to Redis, which queues it. Celery picks up the job in the background and run inference on the GPU. And finally, the result is written to the FastAPI and FastAPI send it back to the user. So this way, the user gets its response for the request it has sent. So it's gonna get an image classification because in this video that is what we are doing. So now let's move on to the coding part. So we start by installing all the libraries that we need for this task. So our first library is FastAPI. Let me give you a brief about all the libraries. So FastAPI is used to build REST APIs. And with the help of these API, the user will upload the image and get its result. Next is UVCon. It's basically a web server which is used along with FastAPI. Next is Celery. It's basically used for background job manager. It processes inference tasks without blocking FastAPI. Next is Redis. So it acts as a messenger between FastAPI and plugin. And the next one is Torch and Torch Vision, and these are our main deep learning libraries which we'll use. The second last is Pillow, which we will use to open and pre-process images. And the last one is pynvml. So it's an NVIDIA library which provides us with its API to check the GPU VRAM, how much it is used, how much it is available, so all those. Okay, so one more is also left, which is logging. So this is also one library which we'll use for detailed logging for all the things which is happening in this entire project. So you can simply install them with a simple command. So you can say pip install r and then requirement.txt. So with this command, they all would be installed because they are already installed on mine. I don't need to run them again and again. Okay. So these are all the libraries. Next, one of the most important thing is the Redis. So let's install that also. Let me show you how you can install that. So it's basically a lightweight in memory database. Basically what it means, it runs on the RAM. So it is fast and it helps with the real-time task. So simply if you are on my system, which I'm using is like Ubuntu, the process is simple. You need to update them and then put this second step. Okay, sorry. Sudo apt install Redis server y. I have already installed it, so I'm not going to do it. Then what you need to do is check its status because it's a service. Paste. Okay, again, sorry, mistake. Okay, let me write my password here. So you can see it's working and active on my PC. So you also need to make sure that it is working on your PC. And let me remove it. And one of the simple thing, if you want to check if it is working on your system, it's a simple type this command Redis CLI, then say ping. It will respond by pong. If it say pong, this means it's working fine. So this is also done. So now we'll start with one of the basic thing that you should start. So I usually start with any backend project with a logger config. So it helps us understand what's happening under the hood, especially when things go wrong. So this is the first file which we check, that is those log files. Anything bad happen, anything unexpected happen, so we usually check the log file. So first of all, let's work with this log file. So we have already installed the logging library. So here's the complete code. So first of all, we import the library, then we import the path. So first of all, we create the folder, the logs folder, in which we're gonna save our all the log files. So we're gonna have multiple log file, each for different activity. Then we have defined a get logger function that create new logger for each module like FastAPI, GPU and other thing. Okay, and every log has a timestamp, level, module name and a message. So this is about the logger. Our next important library or the file is GPU, because our entire model, because we are doing deep learning, would run on GPU. So handling GPU and its VRAM is really essential, and that's why we have installed this pynvml. So let's go back to our file and get our code. So this is kind of not that much big code, but it's a code. So again, we start by logging. Then we have our class, that is GPU manager. So what we'll do here is basically this class job is to check how much VRAM is free before we can run any inference case. Okay, like if VRAM is there, we can run the model on GPU. If VRAM is not there, like it is the whole it is completely occupied, then we can run our model on the CPU. So this is how it's going to work. So first of all, we have our initializer, where we initialize the class and set a minimum threshold frequency, not the frequency, minimum free memory. So we need at least 2 GB of free memory. You can reduce it to 1 GB also. So this is up to you, and you can define it accordingly to your task. So by default, we have set to device to none. So none basically refers to CPU. If it is none, it's CPU. Because my PC has only a single graphic card, that is 1050 Ti. So it's really small, and this code also works fine on mine. But this is built for single GPU. It won't be able to handle multi GPU. Okay. Then here we initialize the pynvml, and here's the function for initializing it. So here we simply just connect to NVIDIA's driver API. Then we have again the next reinitialization function, this check and reinitialize pynvml, because sometimes it gives you an error. So what we do, we again write a function to ensure that pynvml is active inside each Celery worker, and that is important. Our next function is get free memory in MB. So it return free GPU memory in MB or 0 if unavailable. This is to ensure we first check that GPU VRAM is there or not. If it is there, then we can run on GPU. Otherwise, we all know it's going to be run by default on CPU. Then our main function to acquire the device. So in this function, this gives us whether our code or inference thing would be run on CPU or GPU. So first of all, we initialize it, we reinitialize it basically. If it is none, then no GPU self.device. Then we try to check if the free memory is greater than the minimum threshold which we have set. If it is not, then we return. If the free memory is greater than this minimum free memory, it will return 0. That is the ID for your GPU. Because I only have a single GPU, it would by default return 0. Otherwise, it would return none. This means it will run on CPU. And if there's any error, then again we are not going to use GPU, we will use CPU. So that is how we gonna manage things on our GPU. Like if your GPU is large, this file would be good enough because you can run multiple inferences at the same time, because while training you use like large VRAM, but during inference you are not going to use large VRAM. That's why GPU VRAM management is important and how you're going to use it optimally. So our next function is model handling. This is the file. So now we'll write how to load the model, pre-process the input and make prediction. And one of the important code. Let's go to the top. So first of all, we import all the libraries which we need for this task. And we have a logger here to log the model handler. And inside we have a class called model handler. So first of all, we initialize ImageNet labels. Then we have this transform, basically where we resize the image. Then we do a center crop, and then we convert it into a tensor. And after that, we normalize it using the ImageNet mean and standard deviation. So these are really important. These are some pre-processing steps which we need to follow. Okay, let me show you this labels.json file. So this is the file. It contains all the IDs and then the class labels. Then next we're gonna load the model, and here we are using a ResNet 50 because it is pre-trained, so we don't need to do that much stuff. And this is where you can replace your own custom model, and you can have more than one model, so you need to change that code accordingly. But for now we are using a simple ImageNet pre-trained ResNet 50 to simplify thing. Then we have our main function, that is predict. So what it take is the image path and the device, whether it is on CPU or GPU. So first of all, we load our model on that specific device, CPU or GPU. Then inside this try block, because it could give us error, we first read the image and convert it to RGB. We apply those transformation pre-processing step and unsqueeze it, and then put it on the same device as we put it the model. Then we run the inference. We have the model, we give it the image, we get the prediction, we pass it via the softmax and get the top 5 result. Next we prepare the result by putting those top 5 labels and their probabilities in the result list. So here our inference is complete and we give the result back. But in case there is any error in this part of code, we would have an error and we would return error, that the status we're going to give status error, and we're going to give the error back. And finally, when things are done, whether this part of code is run, whether this part of code is done, we're going to clean up the memory. We're going to delete imagt, predict, probabilities, all the variables. And if we are using a CUDA, that means GPU, we empty cache and we synchronize. Basically, GPU memory cleared and synchronized. This is just the cleanup step, because we don't want to unnecessarily occupy the GPU, because other users are also waiting, and if the GPU is occupied, then they may not be able to get their result on time, or they may not be able to get the result and there would be timeout issue. So this is our model handler. Next is the task.py. So now let's set up the Celery Worker that connect everything. So we have already make sure that Redis is working in the background, and we have imported all the required files. That is our GPU manager, model handler, the logger, then this pynvml. So we first have our worker logger, then we have our app, that is Celery. Then we have GPU manager, model handler. Those two important things. GPU, where we're going to run our model handler to get the inference. Then first of all we initialize the pynvml like once, because we also going to log the GPU VRAM, how much occupied is there. Like here you can see the total VRAM, how much it is used, how much it is free. So for that we need to initialize this pynvml. That's why. And as you know, this function, it's basically log the GPU VRAM. Then we have our main function, that is classify. So it's going to take the image path, and first of all it's going to log that it has received the image, device ID none, device 0. So first of all we're going to acquire the GPU. So device ID, acquire device, already know this function, acquire device is studied. Then we're going to check whether it's going to be a CUDA or a CPU. Let's say it gave 0. So it says if device ID is not none. If it is not none, it's going to be CUDA is specified by the which GPU, because I only have one, so it's going to be 0. If it is none, then we're going to use a CPU. Then the device name. So we are using this specified device and we're going to log that information. So here it says log memory before inference. So before inference, if it is a CUDA, then we're going to log GP memory before inference. Then we're going to run the inference. We have model handler dot predict. We're going to give image path and the device. And when inference is done, we're going to log again log the memory. And we're going to say status success and we're going to give the result back. And if there's any error, because error always there, so you cannot be 100% sure that error will not be there. So we always have this try and accept statement. Then we log the error for ourselves so that we can see that why this error. So we log that specific error so we can solve it. And for the user, the client, we send a status that this error has occurred. So instead of giving some random thing, so user also know there's some error. So maybe he can run again and things are fine. And finally, when either of the code is run, whether the try one or accept one, if it is CUDA, then we empty cache, synchronize, and we log that information. Okay. Now this task one is done. We're going to move on to the main part of the code, that is the FastAPI. This is where the user upload an image and get the prediction asynchronously. So let me paste the code. Get back to the top. So we have imported all the libraries which we have here. That is FastAPI, responses, then Celery. I'm always confused. It is called Celery or Celery. I'm sorry if I pronounce this incorrectly. Sorry. Then from task we have classify image. Then from logger we have get logger and all the other libraries which we need. So first of all we have now API logger, the FastAPI logger you can say. Then we initialize the FastAPI. Then we have our uploads folder where the files would be uploaded that the user upload. Here the file would be saved. Then we create that folder. Then this is our default API when we put our that specific access point. So it's gonna give you this information, return a message that this app is running. Here we have two APIs, that is predict and the result. So the predict, what it does, it simply receive image, it save it locally and queue a Celery task. This is what it do. So let's look into it. First of all, it receive a file. Okay. So first we create a database subfolder because we can have more than one image uploaded. So what we do for each date, let's say for today, it's going to create a folder and inside that folder it's going to save the image. So we have this folder, we create that folder. Next we generate unique name because multiple user can upload same name image, so it might be confusing. Let's say two client upload an image of dog. It can be different dog but name could be same. That's why we generate unique file name. So we first get the extension and we generate a unique file name. and then we have the file path, that is the folder, the date folder, then file name. Then we save the file which user has uploaded in our system, basically in the uploads folder. And then we send async task to Celery. Basically it's task, then classify image delay, then we give file path, and we have log that information. So now we're going to give user back the task ID and status that it is in queue. Initially it would be in queue, then it would be in the process, because we need to check GPU memory is there or not. If it is there, then put it in the work. If it is not there, then wait, maybe it's not there, then we occupy the CPU. So this is how it's going to work. And again, if there's any error, we'll give status error and the error message, and also the 500 status code, just to know that there is a server error. Now comes the result API. So what it does, it checks task status and return prediction once they are done. So it's simple. The user will point to this API and the task ID. The function gonna receive the task ID, and what is gonna does is gonna give this task ID to this async result, and from where it is here, from clergy result async result. So we have a result, so it's gonna check the state. If it is pending, it's pending, you would not get result. If it is a failure, say error and give that error. If it is success only, then you're gonna get the result. You're gonna say result.result and then result. Else status would be result state lower. So this is how it's gonna work. So now our most of the task is done. Now we need to test all this. Okay. So let's write the code for testing. And because our this project or the model or the API is able to handle more than one user, so we're going to make sure we use multi-threading and give multiple inputs or the request to the user. So it's kind of big code. And if one of you feel it's a ChatGPT generated, then I have used the help of ChatGPT. I'm not saying I have written this completely, because even I am learning things and you're also learning. So I have learned something and I understood this, how this work. Because initially what I used to do, I used to use Flask or Django. You basically Flask API and just put that model there and use the Flask, and that is how I used to do. But then I feel this is not the right way. Let's improve ourselves and learn. So I was working on something, then I write some code, then I took the help of ChatGPT. That's ask ChatGPT, so how this could be done, how this could be much better. That in that case, I learned there's something called Celery, something called Redis. Initially, I would write those code on myself, but then I find there's something, why should I write my own code? Okay, so let's get back to this test.py. So we have all the libraries which we need. Then we have an API URL, image path, which is inside our test images. So we have two images, cat and dog. Now imagine if two requests with the same name, then and they would be different images. So this would be an issue. And also one issue is also there when I run this test file for, like, let's say 100 requests, then it gave an error because multiple processes are trying to read the file and also trying to save the file on the server. Then it would lead to an error. So I'm not saying it would handle large number of requests. So but decent request it can handle. Let's say 10 requests at a time it can handle. So that's how it's gonna work. It's not a really perfect code. It's just that it can work fine for demo. Maybe you have some project for your college or some demo you need to show. In that case, this one is fine. You can put it on a PC, have that local and locally show the demo. That would be fine. So first of all, we have API URL, image path, then number of requests. Initially, let's put it to 1. Let's test it with simple thing. So first of all, you have function to define the image. So we have a request ID because we have more than one request. So we have request ID. So first we check if image exists or not. If it does not exist, we raise an error. Then we read the image and send the request to the API, that is API URL, then predict and the file, that is file F, because in the main we have the name as file. See, file. So we give the same name. Then if response status code is not 200, we have some error. So we say for this request ID we have some errors. Then because if there's no error, we're going to get to this part of the code, we're going to get the result, that is response from the server. We're going to receive the task ID and we need to keep this task ID because this is how we're going to track. If we lose this task ID, we are not able to track the things. Then we're going to poll the result. What it does, it basically pokes the result API, that if our result is ready or not. Because this is really simple task, so it's not going to take that much time. But still, this function receive task ID, then request ID, then interval. That's because it's going to ping it every time, send it request. So interval is basically gap between two API requests. Then a timeout, that if this much seconds, if 60 seconds has happened, then this means something is there. So we're going to make a timeout error. Okay, so we start the time, we print some information on the screen. Then remember, now see, this is an infinite loop because we're going to ping until we get the result or there is a timeout. So we have try block and accept block. We receive a response when we send the request to this API URL, request and task ID. Just remember, this task ID is important, and this task ID and request ID is different. Request is basically how many requests we are sending. So for each unique request, we have a request number, and for also each unique request we send, we receive a task ID. So these both are unique. Then we receive a response. If not, we have some error and we're going to return none because something has failed. And if status is succeeded, you see here, if it is succeeded, it's going to give you the result. If it is succeeded, it's going to return the result. Okay, if there's an error, we again say there's an error in this request ID, return none. And if timeout happen, see the current time, if we subtract it by the time we start this polling, if it is greater than timeout, if it is greater than 60 seconds, then we say timeout happen, and so we return none. And then this time dot sleep, just because this loop was going to happen multiple times, so we put a gap of 2 seconds. That's for 2 seconds, just wait here and then continue with the function. And this is a simple function to display the result. Then a function for single run test. It would receive a request ID, then inside a try block, it's going to upload the image. So if it does not receive a task ID, there's an error. If there's no error, it's going to poll for the result. If there's some result, it's going to display and return success, else fails. And if there's an error, it also return failed. So this is how it's going to work. Now we go to the main part where we use threading to send multiple requests. Okay, so let me run this. Also remember, before sending using the test, we need to run the thing. So we have two files. First is start local and the stop local. So what start local does, it basically run Redis plugin FastAPI automatically. Okay, so you don't need to do anything, it's going to automatically run everything. See, start Redis, start Clergy. So simply Clergy this. Okay, and it also have this log file and this everything. Okay, this is done. You can update it automatically, and then to stop all the processes, it also has that. So we don't need to work on anything. We simply what to do. Now we're gonna have our environment. This is my environment. Let's say start local. Okay, so it is. So you can see we have logs folder. Okay, and we also upload folder. You can see they are automatically created. And this, so let me show you, like, copy this link and let me show you how it would look in a window. Okay, here's the window. Oh, this is not good. This is not how it would work. Let me copy. It should work like this. Now I'm copying. Yeah. So you can see this is the default API image, the API, and you say ImageNet classification API is running. It's from where? Just a sec. Here, this is the message. See, it's running successfully. So now we have two more APIs, that is predict, but we're not going to use predict from here. What we'll do, we'll use our test file. We open a new shell. 3 test. For now, just one image. Concurrency started with one request. Uploading image. This is our task ID we have received. Waiting for result. Inference complete. Top 5 prediction. And you can see we have some error. And this is normal. And that's why we have log files. Now we're going to, okay, but for this, yeah, we're going to have some error in the log files. Just check them sequentially. Because it's a exception string indices must be integer. So there's something wrong happened. We don't have any error here. In Cloggy, it might be having some error. No. FastAPI, it says something but no error. The GPU manager, things are working. Model handling, fine. Worker, fine. Then what's the issue? We have logged everything and still there's some error. Now that's fantastic thing to work with. Let's again check them, okay, thoroughly. What could be the error? Because this is why we have these log files to check what the error is. Let's check first of all, do we have image uploaded? Yeah, we have uploaded the image now. So let's check it again. So let's do one thing. Let me also activate the same environment. I know this is not the issue, but still. It upload. Okay, there's no error. Maybe it's because, okay, this is also running, but there's some error and we don't even know. Okay, let's leave that. Maybe this is the environment or something related to that. Because after I change the environment, it works. So it uploaded the image, we receive a task ID, waiting for result, inference complete, and we get top 5. So it's a golden retriever. 53.24% it's sure. It's a golden retriever. And yeah, it's golden retriever only. You can see. Oh, these are too much zoom. Yeah. So these are two golden retrievers. Fine. Now how about let's check it for that cat. Name of the image cat.jpg. Okay, let's do that. Let's save it and let's okay, again same thing, we received task ID and things are done. So 27% say it's a tabby, 17% it's a Egyptian cat. Now I don't have any idea what is tabby. Okay, let me also confirm. So our, okay, so we have uploaded cat image. This is hopefully the cat image. Okay, let's say now I don't know what a tab is, but it's cat, Egyptian cat or cat, I can. So but this is not the main thing here. What the inferences are, our main thing is the implementation, and we can see that things are working fine when we have only one request. Okay, now let's do one thing, have more than one request, let's say 5. Let's get back to a dog image. Dog is much better. Okay, so 5 requests you can see. Uploading image, uploading, task ID received. Okay, now you can see string indices must be integer, not string. There is some error. In some case it has some error. See, it is giving error, except string indices must be integer, not string. There's some error, I think, while converting it from those integer to like that labels which we read in the JSON file. So I'm thinking that might be the cause of error. But still, can see things are working. It can handle multiple user. Maybe it does not give you the result. That is another part. But it's even successfully able to handle the error also, no? Let's do it for 10. Or maybe it's not able to, but this could not be an error like we have multiple requests, so it have exhausted all the system. It could not be that. It could be something which I've missed while writing the code and even like copy pasting it. It's able to handle, but still we have string indices must be integers, something. So I need to check that. Like, let's again look at the log files. Maybe this time we have some error. No error. Celery, some error. Please give me some error. So you can see GPU, it's now also logged GPU memory, how much it is free, how much it is available, it's total used, and this thing and that. You can see these magnifying glass indicate I've used ChatGPT. Yeah, I've used ChatGPT in some part of the code. But like it's fun to use ChatGPT in your own memory, but just don't totally depend upon it. That's the main thing, because if you totally depend upon ChatGPT, then you are done. Then no one can save you. Like seriously. Maybe here we can get something. We have some warning. Yeah, we have some warning, info warning. Straight reload detected change in. Okay, we have made some changes, so it is reloading. Okay. Let's see from here. Okay, nothing. Like I'm not able to see any error. Can see how it shows different GPU memory availability. So we can see it's now this much GPU is available. Initially it was this. So like our task. So the thing happen is that the wait file is already there. Okay, but they don't get back, so that because when a new task come, okay, when the new user or new request comes, so it do not need to reload that again. That's why this GPU memory is this. I think that's the reason, but it can be managed more effectively. Let's say for it should be have some timing issue, that if this much amount of time no request came, just empty, just free the VRAM. Why load the model? We can load it again when a new request came. And if continuously we have request, then don't unload those waits, just remain there. If after specific amount of time no request came, just free the VRAM. This could be one thing, but still we are not able to get why do we have that error. Like model handling is fine, there's no error here, no warning. If you see it's info, worker should have something. Please give me something, I'm begging you, please. See, nothing is there. Either I am not logging that thing or there's some issue. I'll solve that. Okay, but I believe this should be the end of the video. Okay, so that's it. We have built a complete deployment system for deep learning model. That is our ResNet 50 pre-trained on ImageNet dataset. I know it's a simple task. You can put your own classification model there, and that would be really nice to see what you have done. And it's asynchronous, GPU aware, production friendly, and also simple enough to run locally. Okay, so maybe in the next version we can solve this error, and also we can deploy some segmentation or object detection model in the same way. And if you want those, please comment below. I'll make that tutorial also. So thanks for watching, and if you found this helpful, don't forget to like, share this video with your friend, and do subscribe the channel. Okay, so thank you, have a nice day.